Okay, folks, what we're going to try and understand in this video is we're going to try and understand absolute value functions, okay? Now, you see the word function here, okay, and you see absolute value, and I understand that both of those separate things are things that you possibly may hate. But what I want you to know is this, is that when we do these, basically, if you understood sort of, at least a good bit of how to graph a linear function and how to identify qualities of a linear function, you're going to be fine with these absolute value functions. And the main reason for that is we're not doing super complicated absolute value functions. We're doing basically linear absolute value functions. And so what we're going to do is we're going to focus on these things over here. We are going to try to identify the intercepts of an absolute value function, the vertex of an absolute value function, and if you recall, a vertex is something that we have in quadratic functions. The reason that a vertex exists in an absolute value function is because instead of just being a straight line, it becomes a shape of a V, and so kind of like a parabola, it has a single point that's sort of either at the bottom or the top of the graph. Okay, so there's going to be a vertex. Also, absolute value functions, just like quadratic functions, are symmetrical. They're like a mirror image of each other around their vertex. Okay, I'm going to show you how to just very basically sketch the graph of an absolute value function, and then I'm going to show you how to identify the domain and range of an absolute value function. We're not going to go too deep here because these concepts aren't as deep as a lot of textbooks make them seem. They are kind of important, and I'm going to talk about them, but they really are a piece of cake. I'm going to show you how to very quickly identify the domain and range of any basic absolute value function. Now, what you're seeing here is an example of an absolute value function. You can see that there are absolute value symbols. We have f of x, which we could just as easily put a y here, and we have an x in there, and so we have a relationship between an input and an output with some additional numbers in there, okay? So why don't we go ahead and jump in and identify the intercepts and the vertex of an absolute value function. Okay, so I want to give you what I call the basic form of an absolute value function, or at least a linear absolute value function. And it's going to look very similar to the slope-intercept form of a line because there is a slope associated with absolute value functions because they are basically linear, but they create, instead of being a straight line up or a straight line down, they create either an upward V or an upside down V, which you could call a mountain. But still, just like lines are straight, the V shape has a straight right side and a straight left side. The upside down V, again, has a straight right side and a straight left side. So basically there is a slope there, a constant slope, okay? So the basic form that we're going to work with, that I'm going to explain, which may be different in different textbooks, it may be different for different professors or instructors, but trust me when I say all of these basic absolute value functions will somehow or another fit into this form that I'm showing you, okay? So it is y equals m, then the absolute value of x minus h plus k, okay? Now what's interesting here, something you may notice is, if you know a bit about math, you can see that this looks a little bit like a linear function, and then the h and k, they have something very similar to the vertex form of a quadratic function. And that's because absolute value functions have some of the qualities of a linear function, and they have some of the qualities of a quadratic function, okay? So this is the basic form, and m is a slope. I don't like to say, we can't really say that it is the slope because the slope harshly changes at the vertex, okay? But I can say that the vertex of the absolute value function is related to this h and k, all right? So let's go ahead and look at an example of an absolute value function. And what I'd like to start with, very simply, probably the easiest thing to do is identifying the vertex of an absolute value function. So that's the first thing we're going to do, is identify the vertex. So if your absolute value function, the one you're looking at, is in the form m times the absolute value of x minus h plus k, then here's how you identify the vertex. The vertex, very simply, is at the point h comma k. All right? Now, it's important to understand that if the signs are different here, that means, for example, if you see something like y equals 2 times x plus 7 and then minus 4, okay? Do you see how this plus 7 is the opposite sign of the minus h, and this minus 4 is the opposite of the plus k? That means that you're going to have to go with the negative versions of those numbers. Okay, so if this is your absolute value function and we want to identify the vertex, well, the vertex is at the point h, that's the x coordinate, comma k, that's the y coordinate. Okay, so here h, if we take our, this says negative h, so if negative h is equal to positive 7, well, now we'd have to divide by negative 1 or multiply by negative 1, right? Divide by negative 1, divide by negative 1, and now h is equal to negative 7. So the x coordinate of the vertex for this is at negative 7, okay? And then the y coordinate is at positive k. So if I bring the k down, and what we have in place of positive k is negative 4. So if I put a negative 4 here, it's saying, look, k is equal to negative 4. So in this case, the coordinates of the vertex of this absolute value function are at negative 7 and negative 4. So we could go over to a coordinate plane and we could go to negative 7, 1, 2, 3, 4, 5, 6, 7, down 4, 1, 2, 3, 4, negative 7 and 4, and this is now the coordinate of the vertex of this absolute value function. Okay? Let's try another one. Okay, here's another one. You might say, hey, I notice there's no number in front of the absolute value symbol. Well, that just means that m is equal to 1. You know, we don't normally write the 1 when it's 1, okay? But you can see that where the h should be, there's a 3, and there's still a minus, and that means that 3 is actually going to be positive in this case, because the minus is here and the minus is here. This says plus 5, and that's plus k, so that means that the 5 is going to be positive, and so our coordinates of the vertex are at 3, 5. Okay? Let's try another one. All right, here's another one. Why don't you pause the video and look at this, see if you can figure out where the vertex is, and then on a sheet of graph paper, plot the vertex on a coordinate plane. Okay. So hopefully you already did this. You paused the video. You already tried it. Now I'm going to do it. Okay, so here this is irrelevant for the vertex. Don't worry about the m. That's for sketching the graph. Just hold off on this. We only care about what's with the x in here, and we only care about what's on the end here. Okay, so x minus h. The h is supposed to be minus something, but since this is plus 1. That means that the x-coordinate is negative. So instead of being 1, it's negative 1. And I want to show you here, so we'll say x equals negative 1. And I'm going to prove it to you. Okay, I'm sorry, not x, h. Sorry about that. H equals negative 1. Okay, so now if I go up here to our basic form and I do x minus and then put negative 1 in for h, I get x minus negative 1. Well, x minus negative 1 means x plus 1, which is what we have here. Okay, so I'm just showing you this is why we know that the h is going to be it's going to be negative 1. Okay, then it should be plus k, but we have minus 8 here, and therefore k is also going to be negative. It's going to be negative 8, and therefore the coordinates of the vertex are negative 1 and negative 8. And negative 1, then negative 8, 1, 2, 3, 4, 5, 6, 7, 8. This now is the coordinate of the vertex of that absolute value function, okay? Let's do just a couple more. Okay, here's another one. Now, I'm sort of throwing you off with a couple things here because I want to explain some things to you. First of all, you may say, well, there's no y here. Remember, f of x and y are basically interchangeable. When we say f of x is equal, we're basically saying y is equal to, okay? You have to get used to this notation because when you get into maybe higher levels of math like pre-calculus and calculus, there are a lot of times you'll be working with multiple kinds of functions, okay? So you'll have f, you'll have g, you'll have m, you have all different letters, okay? And the input can be x or t or v or all kinds of other stuff. All right, so the next thing you might say is, well, there's no k on here. Okay, when there is nothing on the end, that just simply means that k is equal to 0. Because if we had a plus 0 on the end here, why would we write plus 0? So we don't write it when it's 0, and we just understand that k is equal to 0. Up here, you may say, well, there's a negative in front of the absolute value symbol where the m is supposed to be. Well, that just means that m is negative 1, right? Okay, so we don't put 1s there. When m is equal to 1, we don't write the 1. But if it is a negative 1, we do have to put a negative sign there to indicate that m is negative 1, okay? All right, so we know what k is. Now we just got to figure out h. Here's a great way, just so you know, here's a great way to solve for h. What you can do is you can take your x minus 3, set it equal to 0, and then solve for x, and then that'll tell you what your h is. So if we add 3 here and add 3 here, we get x is equal to 3. And when you do that, that gives you your h value. And so h is equal to 3. Now, you don't have to do it that way. You could be the kind of person who just looks at it and says, oh, it's basically just the opposite number of whatever this is. This is a negative 3, therefore h is positive 3, and you would be correct. Okay? So the coordinates of the vertex of this absolute value function are 3, 0. And which is right here. 3, 0. Okay? All right, let's just try one more. All right, last vertex. Okay? Here's our absolute value function. Again, I'm sort of messing with you. You're like, hey, this doesn't look like that because this says x minus a number and this is just an x. Well, that just means that h is 0 because x minus 0 is equal to x. So if you see an x all by itself in here, that just means that the h is equal to 0. So in this case, h is equal to 0. And then whatever you see on the end here with the sign, that is the k. So in this case, k is negative 6. And therefore, the coordinates of the vertex of this absolute value function are 0, negative 6. Okay? And so that will be at 0 and 1, 2, 3, 4, 5, 6. That'll be right here. Okay? And so that is identifying the vertex. Now we're going to identify the intercepts, the x-intercept and the y-intercept of an absolute value function. Okay, so let's go ahead and figure out how to identify the y-intercept and the x-intercept. Now, I want to note something here, that it's actually not x-intercept, it's actually x-intercepts. In most cases, you're going to have two x-intercepts. Now, it could be that you may only have one x-intercept, but that will only happen if the vertex is on the x-axis. The other possibility is this. Just like with quadratic functions, it is possible, I'm going to write down here, possible to have no x-intercepts. And I'm going to show you that example in just a few minutes, okay? Now, here's the cool thing. Finding the intercepts for an absolute value function is the exact same procedure as finding the intercepts for a linear function. In fact, finding the intercepts for almost any function is the exact same procedure. To find the y-intercept of a function, you just plug in 0 for x, and then solve for y. And to find the x-intercepts, you plug 0 in for y and you solve for x, okay? So here, let's find the y-intercept. So we're going to plug a 0 in for x. We're going to put an x or a 0 here. So y equals -2 times the absolute value of 0 minus 1, then plus 8. And now we're just going to evaluate, okay? And so 0 minus 1 is -1. And what's the absolute value of -1? Okay, in fact, let's make a line here. Let's go -2 times the absolute value. 0 minus 1 is -1, and then plus 8. And the absolute value of -1 is 1, positive 1. And positive 1 times -2 is -2. So we have y is equal to -2 plus 8, which -2 plus 8, that equals 6. And therefore, the y-intercept of this function is at 0, 6, okay? So we could go over here to 0, 1, 2, 3, 4, 5, 6, and we could plot a point, okay? All right, so now for the x-intercepts, it says to plug a 0 in for y and then solve for x. So we're going to set this whole thing equal to 0. So we're going to say 0 is equal to -2 times x minus 1 plus 8. Now, this may look familiar to you because just recently we learned how to solve absolute value equations. That's what this is now. It is an absolute value equation, and we just want to solve for x. So we're going to subtract 8 over here, subtract 8 over here, and we get -8 is equal to -2 times the absolute value of x minus 1. Now we're going to divide by -2 so that we can get rid of the -2 in front, and we get -8 divided by -2 is 4 equals absolute value of x minus 1. At this point, you need to stop for a moment and make sure of something. You need to make sure that what is on the other side of this equal sign is positive or 0. It just can't be negative. If it's negative, then there aren't going to be any x-intercepts at all, because the absolute value of an expression cannot equal a negative value. So that's how you know whether there are no x-intercepts. In this case, this absolute value is equal to a positive value. Therefore, there are x-intercepts. So now what we're going to do is, remember, when solving an absolute value function, we get rid of the absolute value symbols and we write the expression inside, x minus 1, equal to this number. And then we write a completely separate one, x minus 1 equals to the negative version of this number. So -4, and now we just solve. Add 1 to both sides, and we get x is equal to 5. And then over here, we add 1 to both sides, and we get x is equal to -3. And so now we have our x-intercepts. Our x-intercepts are 5, 0, and -3, 0, which can be plotted. 5, 0 is 1, 2, 3, 4, 5. That's right here. And then -3, 0 is -1, -2, -3. And these 3 points are on the absolute value function. And what we're going to do in just a few minutes, after we do a couple more examples, is I'm going to show you how to graph an absolute value function, and you'll see that it will fit just fine into these points. Let's do another example of intercepts. Okay, here's another function. Let's go ahead and identify the y-intercept and the x-intercepts. I would encourage you, if you feel confident, to go ahead and pause the video and see if you can figure it out on your own. Okay, so now I'm going to work through, see if you got what I got. And you may have noticed something funky going on. So for the y-intercept, we're just going to put a 0 in for x. So we're going to put a 0 here, and 0 plus 2 is 2, right? So we're going to say y is equal to, we can just switch the f of x, turn it into a y, okay? So 0 plus 2 is 2. The absolute value of 2 is 2. So it's 2 plus 3. So that makes the y equal to 5. That's the y-intercept. So the y-intercept is 0, 5. So the y-intercept of this function is at 0, 1, 2, 3, 4, 5. We'll put a dot right there, okay? Now let's try the x-intercepts. Oops, let's not erase that. Sorry about that. we are now going to plug 0 in for y. Plugging 0 in for y means getting rid of the f of x entirely and just putting a 0 here. So 0 equals the absolute value of x plus 2 plus 3. So first thing we're going to do is subtract 3 from both sides, and we get negative 3 is equal to the absolute value of x plus 2. Now, if you continued solving from here, if you set x plus 2 equal to negative 3, and then set x plus 2 equal to positive 3, you came up with some answers, but those answers are wrong, okay? Because you didn't notice something that you were supposed to notice. When you got to this step, if you didn't notice that we have an absolute value equal to a negative 3, this is impossible in the normal, real mathematical world. Absolute values are never, ever, never, never, ever equal to a negative value. It's just not possible. Now, if there was a negative sign in front of the absolute value of x plus 2, that would mean there was a negative 1 there. And we could divide by negative 1 on both sides, and then this negative 3 would become positive. But what we have here is a positive absolute value expression being set equal to a negative value, and that is impossible. Therefore, at this point, you stop and you just simply say no x intercepts, and you are done. Okay? Let's just do one more example. All right, last example for intercepts. And if you want to, you can also identify the vertex. That'll give you a little bit of practice, so we'll do that. Pause the video, go. Okay, so for the vertex, let's go ahead and identify the vertex first. The vertex is at the opposite of this. This says negative 4, so that's positive 4. 4, comma, and then whatever you see here, negative 10. So the vertex is at 4, negative 10. Okay, so that's at 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is the vertex way down here. Okay, and now we're going to identify the y-intercept. So we're going to put a 0 in for x. Y is equal to 5 times 0 minus 4 is negative 4, but the absolute value of negative 4 is positive 4. 5 times 4 and then minus 10. So y is equal to 5 times 4 is 20. 20 minus 10 is positive 10. So the y-intercept is at 10. So that'll be 0, comma 10. So we can go to 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's the y-intercept. All right. And so I can show you, we know that from the vertex, this straight line is going to go from here all the way up through there. So somewhere in between, it's going to cross over the x-axis. So we know there are x-intercepts. So now for the x-intercepts, we're going to plug in 0 for y. So we're going to go 0 equals 5 times the absolute value of x minus 4 minus 10. And so now, to solve this absolute value equation, we're going to add 10 to both sides. We get 10 is equal to 5 times x minus 4, or the absolute value of x minus 4. And then to get rid of this 5, we're going to divide by 5 on both sides. And we get 2 is equal to the absolute value of x minus 4. Now we can split this up. Now we can say that x minus 4 is equal to 2, and then we can say x minus 4 is equal to negative 2, and then just do two solutions. Remember, we could only do this because this absolute value is equal to a positive value. If this was a negative value, we'd have to say no x-intercepts. But this is a positive value, so we're good to go. We're going to add 4 to both sides, and we get x is equal to 6. Add 4, and we get x is equal to 2, and therefore our x-intercepts are 6, 0, and 2, 0. And here's 2, 0. From here, 1, 2, and 0. And then 1, 2, 3, 4, 5, 6. There's 6, 0. And so, if you can imagine this, I know now that the graph of this function is going to pass through. It's going to go from this y-intercept through that point right there and to the vertex. And so, if you can imagine, this absolute value function is going to kind of look like this. And then, from this vertex, it's going to go through this x-intercept. And so that's going to look something like this. And what you're seeing now is, do you see this V shape? That is the graph of that absolute value function. All right, so what I've got here is a pretty simple procedure for graphing an absolute value function. If it is in the form, remember our form has to be y equals m times the absolute value of x minus h plus k. Now what I've already told you is that given this form, the vertex is at the point h comma k, right? This is an x coordinate, that's a y coordinate, okay? But we haven't really done anything with the m yet. Now the m represents the slopes of the two parts, the two straight lines that make up the v. And this procedure here is showing you how to use the vertex and the m to be able to correctly graph or sketch an absolute value graph, okay? So if you want to pause the video and you want to write these steps down, that'll be very helpful. What we're going to do right now is we're going to go through these steps by graphing this example right here, okay? So this says how to graph an absolute value function. Here's an absolute value function. It is in the form that I need it to be in. And the first step says to plot the vertex, okay? I'm going to do this in, I think I'm going to do this one in purple, okay? All right, it says plot the vertex. Well, what is the vertex of this particular absolute value function? Well, I have x plus 3, and remember, if I have this plus 3 here, I kind of have to switch the sign because it's minus h, right? So the opposite of positive 3 is negative 3. So the vertex is at negative 3, and whatever you see here, that's negative 2. So negative 3, negative 2, that is the vertex of this absolute value function. So I'm going to go to negative 3, 1, 2, 3, negative 2, 1, 2, and I am going to plot a point right there. That is the vertex of the absolute value function. The vertex, here's one way to think about it, right? Vertex, right? Well, this is basically what an absolute value function looks like. That's the vertex. It's basically the bottom of the V. Now, granted, some of them might be upside down, and we'll see that in just a minute. And in fact, I'll explain it to you right now. The vertex would be that point right there. So it's basically the corner of the absolute value function, okay, or of the graph. Now, what causes the absolute value function to be a right side up V versus an upside down V? Well, it's very simple. It's a right side up V if m is positive. So if m is a positive value, like it is here, that's a positive 2, so that means we're going to have a V shape, a right side up V shape. But it's going to be the upside down V shape if the m is negative. So if we had a negative 2 here, or a negative 5, or just a negative sign, then it would be an upside down V, okay? It really is that simple, okay? And you can mess around with this on Desmos if you want to, but it'll probably help you understand it a little more. All right, so our vertex is at negative 3, negative 2, which is right here, and we know that it's going to be opening upward. It's going to be a regular V shape. And now let's go to step 2. It says starting at the vertex, graph a line. So I'm going to start here. I'm going to graph a line starting here, and it says graph a line to the right. That's this direction. So starting here, I'm going to graph a line going this way, and it says that line has to have a slope of m. Well, what is m here? M is 2. Therefore, the line I'm about to graph has to have a slope equal to 2. So from here, I am going to graph a line that has a slope equal to 2. Well, how do I make a slope equal to 2? That's easy. 2 means I go up 2 and over 1. Up 2 over 1. Up 2 over 1. Up 2 over 1, right? All right. And so then I'm going to line up all those points with a straight edge like this. Okay, let's see if I can get this right. There we go. Now, it has to start at the vertex, so I don't want to go past the vertex. I want to start at the vertex and draw a line. There we go. So that's step 2 right there. I did the right side of it. Now let's go to step 3. Step 3 says starting at the vertex, graph another line backwards to the left. So starting at the vertex, I'm going to draw another line going backwards, the other direction. And it says that that line has to have a slope equal to negative m. So m is 2. So that means the slope of this line has to have a slope of negative 2. Now, I know normally, see, here's what you're going to want to do. You're going to want to go down 2, forward 1. But that's not to the left, that's to the right. Do not go down 2 over 1. What you're going to have to do is this. You're actually going to have to go up 2 and back 1. Instead of doing it as negative 2 over 1, you're going to have to do it as 2 over negative 1. Up 2, backwards 1. This is our change in y. This is our change in x, right? So our change in y has to be up 2, and our change in x has to be backwards 1, because we are drawing the line backwards. And because we're drawing it backwards, that means that the x portion has to be the negative portion. So we're going to go up 2, backwards 1. Up 2, backwards 1. Up 2, backwards 1. Okay? And there we go. Now line them up. Let's see if I can get this. There we go. That looks about very close. There we go. And draw the line. Well, I should have started here and drawn it backwards. Okay? And now you can see our V shape, and we are good to go. Now, I do want to point something out to you. Let's say that you're not very good at this step 3. You're having a hard time doing the negative slope or the opposite slope backwards. One of the things that you could do, see where the vertex is? You could draw a vertical line or a dashed line at the vertex. That's called the axis of symmetry. And what you can do then is, for every one of these points that you plotted over to the right, you can go an equal direction to the other side of the axis of symmetry. This point is 1 unit over from the axis, so I can go 1 more unit over here. If I count from here 1, 2, then I can count 1, 2 again. From here 1, 2, 3, then I can count 1, 2, 3 again, and I can plot mirror points so that it is symmetrical. Okay? All right, so I think we should probably do at least one more example, and then I think you'll have this. All right, so now we're going to graph this absolute value function. Y is equal to negative absolute value of x minus 5 minus 3. Okay? Now I think what you should do is pause the video if you feel confident enough and see if you can graph this. All right, so now I'm going to go ahead and try it. So it says step 1, plot the vertex. The vertex is going to be at 5 and negative 3. 5, negative 3. So I'm going to go over here to 1, 2, 3, 4, 5, 1, 2, 3. So that's right here, 5, negative 3. That's our vertex. Then it says, now note there's a negative in front of the absolute value. That means that this is going to be upside down, right? Now you might be saying, well, what is the m if there's just a negative there? Well, in this case, the m is equal to negative 1. Okay, so the m we're working with is negative 1. Step 2 says, starting at the vertex, graph a line to the right with a slope of m, which is negative 1. So I want to draw a line, or I want to sketch a line that has a slope of negative 1, and I want to start at the vertex. So from the vertex, a slope of negative 1 goes down 1 over 1. Down 1 over 1. Down 1 over 1. Okay, so I'm going to be drawing a line right along here. Now I have to start at the vertex. Okay, so don't go this way. I need to start here and to the right draw a line that has a slope of negative 1. So that is the right side. Now it says, starting at the vertex, graph another line backwards to the left with slope negative m. So if m is negative 1, this one's going to be negative negative 1. Negative negative 1 means positive 1. So over here, now like I said, we're going to want to do, instead of going down one, forward one, we're going to want to go, since it's positive, we can either go back one. Well, really, we're going to have to go back one, down one, okay? Another thing you could do is, I told you, you could make a symmetrical, you could draw the axis of symmetry, and then you see this point right here is 1 unit over from the axis of symmetry, so we have to go 1 unit over here. From here, we go 1, 2 units over, we're going to go 1, 2 units over, okay? And I understand that it's hard to draw a line that has a positive slope that's backwards from a point, but just understand that it has to look like a V. So if this goes here, the other part has to be going this way, okay? So basically from here, we have to draw a line that has a slope of 1. And I know that that's weird sounding, because you're like, yeah, but you're going down, right? Yeah, well, from the left to the right, watch what the line is doing. If we go backwards, but look at the slope. The slope of this line, if we were going from the left to the right, it's up 1 over 1, up 1 over 1, up 1 over 1. This has a slope of positive 1. And so what you're looking at here now is the graph of this absolute value function. All right, so I think a lot of people get really frustrated when they're asked to identify the domain and range of a function, okay? And I think one of the reasons why people get frustrated with the domain and range is that oftentimes when they're first taught about domain and range, they're taught about it using functions that have no restrictions on domain and range. And therefore the domain is all real numbers and the range is all real numbers. Then they start being introduced to functions that don't include all real numbers, and then it's confusing to them, okay? So I'm going to try and simplify it. Very simply, the domain of a function is all of the numbers that can be plugged in for x without breaking the rules of math. Okay, so for example, let's say that I have y is equal to the square root of x. Now, we know that the rules of math say that you can't take the square root of a negative number, right? Now, I get that there are like complex numbers and stuff, but I mean in the normal real number world, we can't do the square root of a negative number. And therefore, you are not allowed to plug a negative value in for x. Now, you could plug in 0, and you could plug in any positive number, but you can't plug any negative numbers in for x in this function. Therefore, the domain of this function is x is greater than or equal to 0. So all of the numbers that can be plugged into x are 0 and any number larger than 0. And so this is how we would write the domain of this function. Another interesting thing is that the answer, so now when we go to range is all of the numbers that can be outputs or the answers for the y value. So let's say I do plug in a legal input like 4. Well, the answer for y is going to be a positive number. Now, it actually can be a negative number, but not as a function. As a relation, the square root of 4 can be positive 2 or negative 2. But as a function, we can only, when we do the square root of a positive number, the answer we always go with is the positive value. And therefore, the range is similarly, so if I put a 0 in here, the square root of 0 is 0. So y can equal 0. But if I put 4 in here, the square root of 4 is going to be positive 2, not negative 2. Therefore, I'm going to say that the range of this function is also y can have any answer that is greater than or equal to 0. So the domain of this function is x is greater than or equal to 0, and the range of this function is y is greater than or equal to 0. Okay? But now when we think about absolute value functions, it's a little different, or at least really only the range is restricted. See, with absolute value functions, you can plug any x value in. Like you might think, oh, well, aren't you not supposed to have negatives here? No, you can have negatives here. you're not supposed to have negatives on the other side of the equal sign. So I can plug negative 100 in here. Negative 100 minus 5 is negative 105, and the absolute value of negative 105 is positive 105. Okay, cool. I can also plug 0 in. 0 minus 5 is negative 5. Absolute value of negative 5 is 5. I could plug in 1,000, positive 1,000. 1,000 minus 5 is 995. The absolute value of 995 is 995. So I can plug any value in for x. And so here's the way we write the domain for an absolute value function. When you can plug in any x value, one way to write the domain looks like this. That x can be less than or equal to infinity, meaning it can be any number smaller than infinity, okay? And it can also be any number that's greater, or not or equal to, I'm sorry about that. Take that back. Sorry, x, not less than or equal to, less than, because you can't reach infinity. You can't be equal to infinity. X can also be any number larger than negative infinity. And so by saying x is greater than negative infinity and x is less than infinity, all of the numbers fall between negative infinity and positive infinity, and this basically means that all numbers are included in the domain. You can plug any number in for x in an absolute value function, okay? But now let's look at the range. For the range, there is a restriction. And the way I'm going to try and help you understand the range is by looking at this absolute value function that we had graphed previously, okay? I want you to notice that, okay, here's the y-axis, right? And this point right here, this is y equals 1, right? That's 1. And this is y equals 2, and this is y equals 0, and this is y equals 3, and this is y equals negative 1. And my question is, are any of the points on this graph, do any of the points on this graph include these y values? Okay? So like this point right here, that's the point, that's at a height of negative 3, right? It's 5, negative 3. But now look, on both sides of this point, the graph is below negative 3. So we've got negative 4 included, we have negative 5 included, we got negative 6 included, all the way down to negative infinity. But look at this. If we go across at negative 1, the absolute value graph is not there. If we go over at negative 2, the absolute value graph is not there. Even if we go across, here's like negative 2.999. At negative 2.99999, the point is just below that. And therefore, negative 2.999 is none of the points on the graph include a y-coordinate of negative 2.999. And so, the range is asking us, well, what are all of the y values, all the y coordinates that are included on the graph? Well, here we can clearly see that all of the y coordinates are less than negative 3. And therefore, we would say that the range of this particular function, we'd say range is y is less than or equal to negative 3, because negative 3 is included. Okay? Any number less than or equal to negative 3. So now you may say, well, is there an easier way to do it than that, Mr. Ryan? There sure is. All you have to do is look at the function. Do you know where that negative 3 comes from? It comes from here. It's the k. All right? And the fact that we chose less than negative 3 is because of this negative right here. And so I'm going to give you a couple indicators here. Just write this down. How to identify the range of an absolute value function. Okay? If m is positive, which in this case it's not, it's negative. If m is positive, okay, the range is y is greater than or equal to k. If m is negative, the range is y is less than or equal to k. And that is all. That's how you identify the range of an absolute value function that is in this form. Okay? All right, well, that's all I have to say about absolute value functions. I'm sure I'll give you some kind of electronic worksheet that has plenty of practice problems on it. And if you have any questions, let me know.